All right, it's recording. Exercise 3I. Exercise 3I is just getting you to, once you've learned the key exercise, which is 3D, 3E, okay, you've learned how to read the transformation, you learned how to figure out the transformation equation as well. If you didn't know as well, there's actually three scenarios that you can get when you're doing 3D. Okay, the one that I think exams normally put in is scenario 3. So this is just a note for yourself. When you're doing exercise 3D, and if you do any past exam questions, 3D has three scenarios. You either go from a simple equation, okay, so simple, and then you transform to a complex one. So for example, x minus 1 squared plus 3, okay? So then you have to figure out that equation. Versus, you might go from complex. So let's say x plus 4 squared minus half to x squared. So you go from complex to simple. The one that I think the examiners normally chuck in, and if you do the sort of end of your chapter, they usually chuck this one in, is when you do, let me just write this, complex, C for complex, and then this is S for simple. S for simple, is when you go complex to complex. So when you do x plus 4 squared minus half, and then you try to transform it to negative x squared plus 1, hypothetically. Okay, so complex to complex, same technique, but that one there is more typical of an exam question. This is more typical of your exercises. Okay, so you might find one or two that's like that. That's worthwhile knowing. Okay? All right, today's lesson. What I want you to write in your notes are two things. Because you're going to get the printed version anyway. So I just want you to copy in your notes for transformation notation. Can you copy this notation down? And then this one. And then I'm just going to add in one more thing that I think could help you understand as well. Now I'm just going to do this because this is my way of thinking about it. I'm going to put a dash on them, okay? Copy what I just highlighted for you, please. Just those as a notation, just to understand what it's trying to say soon. Okay, so the T means transformation. The little negative one means inverse transformation. If you're wondering about this, I can explain it as well. You know how we normally say this is your domain? So because it's domain, it's only one axis, it's one plane. So that's why they usually use R. Why do they do R squared? It's because that means your function has X and Y. It means there's two lines going around. Correct. That's right. Because it's there's two axes, two numbers. You're working on two dimensions rather than one dimension. That's why. So usually you're familiar with F, R maps to R. It just means you're working in just a domain, so it's just one axis. But in our case, we're working with X and Y, so hence it's two axes, therefore two dimensions. Okay? So ignore that for now. We're just going to look at the properties, because that's how you're going to then go through and understand what the questions are asking. What this is asking or telling you is that if you did the transformation or inverse transformation of your x dash y dash, that brings you back to the original xy coordinates. Yeah, that's all it means. So if you did transformation of your original xy coordinates, well, that gives you new x, new y. Logical, right? What you're used to seeing so far from 3D was you're used to saying original xy maps to, x dash, y dash. These two are both exactly the same things. Okay, so you're just saying there's a transformation applied to this to get to the final. Here I'm just saying transformation as a function of x and y. So if you sub in x, the original y, into this transformation, You get that. Okay? The table up here was to summarize what you already learned. Yeah, so what you already learned that, if you put a negative on front of the y, that's a reflection of the x-axis, all the same idea. Okay? Now, let's work on some examples just to see how these three things I highlighted that I want you to copy down to understand. It's more of a language, so it's not so much that you're doing something new. Exercise 3I, question 3, and by the way, on this exact page as well, I've done many examples on the side, so if you want to have a look, you can see my examples on the side as well. Okay, so if I zoom out, I've done many examples just so that you can see with videos, so you can follow that if you're having troubles. Okay? And I think I did some questions too, yeah, so if you keep scrolling down, I do other questions down there too. Okay? All right, so where are we up to? Whoops, this one. These are the three I wanted you to highlight. What they're trying to say is, what if you had a transformation, okay, and we call it T1, so a type of transformation for the xy coordinate follows this pattern. 2 times the original x, 2 times the original y, minus 3. So essentially it's saying dilation of factor 2 from the y-axis, dilation factor 2 from the x-axis, and then down by 3, yeah? This is your second transformation as a function, and it's just simply reflection to the right by 2, reflection again, and then down by 3. Yeah? So very similar to how we've been doing it. When they say find the rule for T2 of T1xy, it looks scary, but all it's saying is it's a composite function. They're saying take this, whatever this coordinate is, sub it into this. What is this equal to? Well, this is your x coordinate, and that's your y coordinate. So that means they're saying take the x's, sub it into the x's here. Take the y's, I'm going to highlight it. So take the x's, and substitute into the x. Take the y's and substitute in the y's, because that's what it's saying. Take T1, sub it into T2. So if you do that, you're really just substituting 2x over here. If I did the first one, so A, T2 of T1 of xy coordinate is equivalent to you saying, I'm going to replace that x with 2x. So it's negative of 2x plus 2. I'm going to take the y coordinates here and I substitute into T2. So then that means this now becomes negative of 2y minus 3 minus 3. See what I'm doing there? I'm just literally replacing the y coordinates and the x coordinates. That's all I'm doing. Okay? If you simplify that, that gives you now negative of 2x plus 2, and that gives you negative 2y plus 3 minus 3, which cancels out, and that gives you negative 2x plus 2, negative 2y. So that's what they mean by finding the rule for T2 of T1. Okay, so far pretty straightforward. It's what you've done in exercise 1E, composite functions, except now you're using transformation functions. Okay, so you can have a go with the second example. Same idea, it's just the reverse. So you substitute the x, negative x plus 2 into this, and then negative y minus 3 into y over here. Okay, what I'm more interested in is the back one. So if you flip over, oh, actually you don't have the page. If I flip over to the next page, over here, just going to rub all this out. This is exercise 3I, question 8b and C. You're familiar again with how to work with mapping notation. And there's nothing wrong with mapping notation. It's just that if they use transformation functions or transformations, you need to be able to read it. Okay? So this is how we used to do it. We used to say, this will give you new x, this will give you new y. So that means you have new y is equal to x plus 2, and then new y is equal to, new x is equal to x plus 2, and new y equals y minus 3, right? Then what you would have done in exercise 3D is you rearranged it to say, well, what's original x equal to? Original x equals to new x minus 2. And then you would say over here, original y is equal to new y plus 3. Fair call? Okay, so that's what you're used to. Today, we're just changing it. Instead of saying xy going to x plus 2, y minus 3, they wrote it here. They wrote transformation S function of the xy coordinates, which is your original xy coordinates, gives you this. That's the transformation. Okay? What they want you to do is they say, find the inverse of the following transformations. So when you find the inverse, you really just want to know, you're literally doing this. This is my inverse. That's the inverse, yeah? But when they write it, they want you to write it in a particular way. So here, the only difference is you would say something like, let the transformation inverse function be of your xy coordinates. So remember that note I gave you up here? I said that the inverse of your new x, new y will give you original x, original y. So that's what I'm doing here. I'm saying inverse of xy will give you original x, original y. Okay? What we understand also, and if I just let, if I say now, we don't know what this original xy is, that's what we're trying to figure out, just like how I did here. I don't know what x is, I don't know what y is. I can call it AB. So A is your x, B is your y. Yeah, what I'm trying to figure out is this. So what they say is, all right, well then, according to the property I gave you, I said, transformation S, if I substituted S inverse of x dash y dash, what is it equal to? What's the property I asked you to copy down? What is it equal to? xy. So that's your original xy, right? So here, I'm writing the same thing. This will give you original x, original y. But what's interesting is that S inverse x dash y dash is equal to A and B. Okay, so this thing equals AB. So technically, what I'm really solving for is S of AB. Does that make sense? Yeah, so what I'm really doing here is I'm saying S of AB. You see that? I'm just saying this here is equivalent to that, and since that's equivalent to this, I'm just replacing it. Yes? So, that tells me that original x, original y will equal to whatever the original transformation is if I sub in A and I sub in B. And that's what you did in the previous example. The previous example was you subbed in the values, and so S of AB, that's literally following the transformation, it'll be A plus 2 and B minus 3 is equal to xy, right? So very similar to how we've got it here. Can you see how I've got A plus 2 and that's x plus 2? That's y minus 3 and that's same as that. So it's B minus 3, same idea. Yeah? And all you're doing here is then you can then say, since x equals to A plus 2 and since y equals to B minus 3, so I'm going to write here, since x is equal to A plus 2 and y is equal to B minus 3, remember what you're trying to find is you're trying to find that A and B. You want to know what is that transformation because it's the original x, original y value, right? So I just got to rearrange to find A and find B. Same thing. If you rearrange that, you get A equals to x minus 2. And then if you rearrange this, B is equal to y plus 3. And that is exactly the same as what I got here. Get me? Okay, so what makes it tricky is because you're used to doing this way. There's nothing wrong. You can probably still solve it even if I didn't teach you the transformation. I just told you to do this. You'd still be able to do it. It's just that knowing how to read what it means. Yeah, so your answers in the back as you're going through it, try to understand what they're trying to say. But that bit there, that's all I'm doing. I'm just following the 3 properties I asked you to copy down. Make sense? That's 3i. So 3i is nothing new. It's everything that you don't know already. It's just learning the language, the notation for it. Okay? All right. I want to leave that there because today's lesson has been way off. That quiz took too long. and then the solutions took too long for it too. But that's 3i. Tomorrow's session, we can slow down as well. It's just 4a. I can normally combine 4a, b, c, but just do 4a and give you some time to work on 3i as well. Cool? We've only got about 6 minutes left, so there we go. What a session today. It's a bit, and no printing. So interrupting. All right, I'm going to stop the